All right, so get this. You sent us some research about a new way to detect COVID-19 using chest x-rays.
Uh-huh.
And
Yeah.
let me tell you, it blew our minds. We had to like dive deep into this one, especially with all this talk about AI and healthcare these days. It's called 4S-DT, and it's seriously clever stuff.
Yeah.
We're lucky to have our expert here to kind of break it all down for us.
Thanks for having me.
You're amazing at like making sense of complex medical and AI research.
Well, it's definitely a fascinating area. 4S-DT, it combines several powerful AI approaches in a way we haven't really seen before.
Yeah, you clearly have a knack for finding like cutting-edge research.
Well, I try.
So before we get lost in all the acronyms and stuff,
Sure.
Let's start with the basics.
Okay.
Why is diagnosing COVID-19 from chest x-rays such a challenge in the first place? I mean, you see it on an x-ray, it's there, right?
Well, it's not always that simple,
Yeah.
especially in the early days of the pandemic. There wasn't a lot of data to train these AI models on. And even with enough data, you can run into problems.
Oh, okay.
Think about how similar a chest x-ray of a COVID-19 patient might look compared to one with SARS. It can be really tricky even for experienced doctors.
So it's not just about having enough data. It's about having data that's distinct enough for the AI to learn from.
Exactly.
That makes sense.
Ah.
Okay, so that's where this 4S-DT comes in.
Right.
First of all, what does that even stand for?
4S-DT stands for Self-Supervised Supersample Decomposition for Transfer Learning.
Oh.
It's a mouthful, I know.
Yeah, it is.
But each part is important.
Okay, let's unpack that a little bit.
Okay.
What's self-supervised all about? It sounds like the AI is teaching itself.
Yeah.
Which seems a little wild.
It is pretty wild. Imagine like a detective piecing together clues without being explicitly told what to look for.
Okay.
That's kind of what self-supervision is like.
Right.
The AI learns from this massive amount of unlabeled chest x-ray images,
Wow.
just finding patterns and connections on its own. This is a big deal because labeling medical data can take forever and costs a lot of money.
Oh, for sure.
Yeah.
So it's basically learning the language of chest x-rays
Yeah.
before even trying to diagnose COVID-19.
Exact.
Pretty efficient, if you ask me.
Yeah, very efficient.
But hold on, you mentioned something called supersample decomposition.
Right.
What's that all about?
Okay, so think of it this way. Imagine you have a huge box of puzzle pieces,
Okay.
all jumbled together.
Right.
Supersample decomposition is like sorting those pieces into groups based on their shapes and colors, even without knowing what the final picture is supposed to be.
Okay, so the AI is clustering similar x-rays together.
Yeah.
But how does it decide what's similar in the first place?
It uses something called an autoencoder,
Okay.
which is a neural network that learns to compress and then reconstruct the images.
Right.
It's basically finding a unique fingerprint for each X-ray.
Okay.
And then they use a clustering algorithm to group X-rays with similar fingerprints together.
I see.
And finding the right settings for this was really key.
Okay.
If the settings are too broad, everything gets lumped together.
Right.
If they're too narrow, you miss important connections.
Oh, interesting.
Yeah.
You're essentially using the AI's own pattern recognition to create a preliminary map of the data even before you have real diagnoses.
Exactly.
That's impressive. Okay, what about those pseudo-labels you mentioned earlier?
Yes.
They sound kind of made up.
That's a good way to think about it. They're temporary tags based on the clusters the AI created.
Right.
And remember, the AI is still learning at this stage.
Wait, pseudo-labels?
Yeah.
Isn't that like letting the student grade their own homework?
Kind of. But think of it like practice quizzes with answers that are mostly right.
Okay.
The AI gets to test its understanding and refine its knowledge. It's not perfect, but it's a crucial step in the learning process.
Right.
And these pseudo-labels are only used for a short time before moving on to the real deal.
Oh, okay.
Yeah.
I'm starting to see how this all fits together. The AI learns from unlabeled data. It sorts the x-rays into these clusters,
Right.
assigns these temporary labels.
Yeah.
What happens next?
Yeah.
This is where it gets really interesting, right?
Absolutely. That's where transfer learning comes in.
Okay.
The final piece of the 4S-DT puzzle.
All right.
It's like training a dog to fetch.
Right.
You don't start from scratch.
Right.
You use their existing knowledge of retrieving
Yeah.
and fine-tune it for a specific task.
So instead of teaching the AI about chest x-rays from scratch,
Right.
you're leveraging its pre-existing knowledge of images.
Exactly.
Clever. Where does that pre-existing knowledge come from?
So in this case, the AI uses knowledge from a pre-trained model like ImageNet.
Okay.
This model has already learned to identify a wide range of objects in everyday images.
Wow.
Imagine a dog who already knows how to fetch a tennis ball.
Okay.
Now, you want to teach it to fetch your slippers?
Right.
You can use its existing fetching skills and fine-tune them for this new task.
Right. So the AI has already gone through like a rigorous puppy school of image recognition.
Yeah, exactly.
That gives it a huge head start compared to starting from scratch.
Right.
And then you fine-tune it specifically for chest x-rays.
Precisely. The researchers use techniques like shallow tuning and fine-tuning to adapt the pre-trained model to the specific nuances of chest x-rays.
So now our dog knows how to fetch slippers instead of tennis balls.
Exactly.
Fascinating. The AI is essentially building on its existing knowledge and expertise.
Yeah.
But how does it actually make the final diagnosis? Does it just like look at the x-ray and say, yep, COVID-19, or nope, all clear?
It's a bit more complex than that.
Okay.
Remember those pseudo-labels?
Yeah.
They play a key role in this final phase.
Okay.
Which the researchers call downstream training.
Downstream training. Okay, I'm intrigued. Tell me more.
All right. So essentially, the AI goes through this like 3-phase learning process.
Okay.
Phase I is that super sample decomposition we talked about.
Right.
Sorting those puddle pieces. Then in phase 2, it uses those temporary pseudo-labels to practice with what we call pretext training.
Pretext training.
Think of it like doing drills before the big game.
Right.
Finally, in phase 3, the AI uses real labeled data to fine-tune its skills for COVID-19 detection.
Okay.
It's like our fetching dog graduating from slippers to fetching specific items on command.
So it's like the AI is going through medical school,
Exactly.
learning from textbooks, practicing on simulations, and finally working with real patients.
Yeah.
Okay, I'm following you.
Right.
But how well does this all actually work? Can it really tell the difference between a COVID-19 x-ray and a normal one?
That's the million-dollar question. The researchers put 4S-DT to the test on 2 different COVID-19 datasets.
Okay.
The first dataset was a bit smaller and had some imbalances, meaning there weren't equal numbers of x-rays for each category, like COVID-19, SARS, and normal cases.
Sounds like a real-world scenario where the data isn't perfectly organized.
Exactly.
How did 4S-DT handle that?
Actually, really well. They used a technique called data augmentation, which is like creating virtual copies of the images with slight variations.
Right.
Imagine you're trying to learn a new dance move.
Okay.
You watch it from different angles, you practice it slowly, and you speed it up.
Right.
Data augmentation does something similar for the AI, helping it learn better.
So they're basically giving the AI extra practice.
Yeah.
With different versions of the same x-ray.
Exactly.
Clever.
Yeah.
What kind of results did they see with this first data set?
With this augmented data, 4S-DT achieved an accuracy of 97.54%.
97.54. That's really impressive, especially given the limited and irregular data.
Yeah.
It sounds very promising.
It is, and what's even more remarkable is that they were able to correctly identify all of the real COVID-19 cases.
Wow.
Not a single one was missed.
Okay, you've got my attention.
Good.
But you said they tested it on another data set, right?
Right.
Tell me about that one.
Okay. The second data set was larger and publicly available, with a more balanced mix of COVID-19, normal, and pneumonia cases.
Okay.
And get this on this data set. 4S-DT reached an accuracy of 99.8%.
99.8%. Seriously. That's almost too good to be true.
I know, right? It's pretty mind-blowing.
How is that even possible?
Well, they even double-checked their work by using different pre-trained networks,
Yeah.
like VGG19, ResNet18, and GoogleNet.
Right.
The results were consistently impressive across the board. So it's not just a fluke or a lucky coincidence. 4S-DT is the real deal.
Okay, so we've got this super smart AI that can detect COVID-19 with incredible accuracy.
Right.
But let's step back for a moment.
Okay.
What does this mean for the average person? How could this technology actually be used in the real world?
That's a great question.
Yeah.
Right now, 4S-DT is still being researched.
Right.
But just imagine you could walk into a clinic, get a chest x-ray, and get a near-instant and highly accurate diagnosis for COVID-19.
Wow.
Think about how much faster and easier that would be than waiting for PCR test results.
Oh, yeah, for sure.
This could be a game changer,
Right.
especially in areas without widespread access to testing.
It could help doctors triage patients more effectively,
Right.
get people the right treatment faster,
Exactly.
and even track the spread of the virus more accurately. Plus, you mentioned earlier that this could go beyond COVID-19.
Yeah.
It's not a one-trick pony. Right.
Exactly. The researchers believe this approach could be applied to all kinds of medical imaging challenges.
Oh, wow.
Think about pneumonia, tuberculosis, even early signs of cancer. The possibilities are pretty exciting.
It's like having a super-powered AI radiologist.
Yeah.
Working alongside human doctors, helping them make faster and more accurate diagnoses.
Exactly.
That could really change the face of healthcare.
And that's not even the best part.
Oh, there's more.
The researchers are already working on future developments for 4S-DT, like adding in multimodal data.
Hold on. Multimodal data. What does that even mean?
Think of it like this instead of just looking at the X-ray. The AI would also consider other information like the patient's medical history,
Right.
lab results, and symptoms. It's like giving the AI a more complete picture of the patient's health.
So it's like giving the AI even more clues to work with.
Right.
Like a detective gathering evidence from different sources to solve a case.
Precisely. This could potentially make the diagnoses even more accurate.
Right.
They're also working on something called an explainability component,
Okay.
which is essential for doctors to trust and understand how the AI is making its decision.
That makes sense.
Yeah.
Doctors need to know what's going on under the hood.
Right.
Not just blindly trust a machine's output.
Exactly.
How would that work?
It means designing the AI to show its work, so to speak.
Yeah.
So it could highlight the specific areas on the X-ray it's focusing on.
Right.
And explain why it's making a particular diagnosis.
I see.
And this is where machine teaching comes in,
Okay.
where doctors can guide the AI and help it learn even faster.
So it's a true collaboration
Yeah.
between human doctors and AI working together to improve patient care.
Exactly.
I love that idea.
It's a powerful concept. And there's even more on the horizon.
Okay, tell me.
The researchers are also looking into ensemble learning and network pruning.
Okay, I'll admit I need a little help with those terms.
Yeah.
Break them down for me.
Ensemble learning is like having a team of AI specialists working together,
Okay.
each with their own strengths.
Right.
Combining their expertise can lead to more robust and accurate results.
So it's like getting a second opinion,
Right.
but from a whole team of specialists, each with their own expertise.
Exactly.
Makes sense. And what about network pruning? That sounds a bit aggressive.
It's not as scary as it sounds.
Okay.
Network pruning is basically trimming the fat from the AI model.
Okay.
You get rid of any unnecessary complexity, making it more efficient and streamlined.
Right.
Without sacrificing accuracy.
So it's like cleaning up a messy desk.
Yeah.
You get rid of the clutter, but you keep all the important stuff.
Exactly.
I like it.
The goal is to make 4S-DT as powerful and efficient as possible so it can be used in hospitals and clinics worldwide.
It's truly incredible to think about how much potential this technology has. We started with a seemingly simple goal detecting COVID-19 from X-rays.
Right.
And now we're talking about revolutionizing healthcare as we know it.
That's the beauty of research. It often starts with a specific problem,
Yeah.
but can lead to breakthroughs with far-reaching applications.
Yeah.
And 4S-DT is a fantastic example of that.
Well, I have to say, this deep dive has been truly eye-opening.
Good. I'm glad.
Now I'm starting to think 4S-DT actually stands for Seriously Smart and Super Exciting Diagnostic Technology.
I think you might be onto something there.
It's definitely a technology to keep an eye on. But before we get carried away with the future,
Okay.
let's make sure our listener is up to speed.
Sure.
Absolutely. So to recap, 4S-DT is a revolutionary new way to detect COVID-19 from chest X-rays.
Yes.
It's especially powerful in situations where data is limited or irregular, which is often the case in medical imaging.
It's a game changer. And remember those 3 key ingredients.
Yeah.
Self-supervised learning,
Right.
super sample decomposition,
Oh,
and
yeah.
transfer learning.
Yeah.
Each of those plays a crucial role in the AI's success.
So self-supervision lets the AI learn from tons of unlabeled data.
Right.
Supersample decomposition organizes that data into meaningful groups. And transfer learning lets the AI use its previous knowledge of images to get a head start on the diagnosis.
Exactly.
But a real triple threat.
Exactly. And remember those results.
Yeah, those were amazing.
We're talking about nearly perfect accuracy on 2 different data sets. That's not something to sneeze at.
No kidding. Plus, this technology could go way beyond COVID-19,
Right.
helping us detect other lung diseases and maybe even early signs of cancer.
Yeah, it's really promising.
It's like having an AI sidekick working alongside medical professionals to push the boundaries of what's possible in healthcare.
And remember those exciting future developments we talked about? Yeah.
Adding in multimodal data, the explainability component,
Right.
the possibilities are pretty incredible.
It sounds like we're on the verge of a major paradigm shift in healthcare.
I think so too.
And 4S-DT is right at the forefront of that shift.
Absolutely. But now I want to turn the tables and ask you, our listener, what really stood out to you?
Ooh, good question.
What implications resonate the most?
That's a great question. And perhaps even more importantly, if this AI can achieve such incredible accuracy with limited COVID-19 data, what other medical mysteries could it help us solve?
Right.
What other diagnoses could it revolutionize?
Hmm.
These are questions worth pondering.
Yeah, those are some really huge questions to think about.
Yeah, for sure.
It really feels like we're on the edge of like this whole new era in healthcare.
It is. It is.
You sent us this research.
Well, yeah, I thought it was fascinating.
And I have to say, you have a knack for finding the most fascinating stuff.
Oh, thanks.
Seems like 4S-DT could be a total game changer, not just for COVID-19, but for like all sorts of medical diagnoses.
Yeah, I think so too.
I mean, if it can achieve this level of accuracy with limited COVID-19 data, just imagine what it could do with other diseases.
Right.
Like early cancer detection, maybe?
Yeah.
Or identifying subtle signs of neurological disorders.
I mean, the possibilities are really, really exciting.
The possibilities are mind-boggling. It's like we've opened this door to a whole new world of medical possibilities.
I agree.
And the best part is the researchers aren't stopping there.
Yeah.
They're already working on making 4S-DT even better.
Yeah. They're exploring ways to incorporate even more data.
Right.
Not just the x-rays themselves, but also things like patient history, lab results, and symptoms.
Wow.
It's like giving the AI this more complete picture of the patient's health.
Right.
Which could lead to even more accurate diagnoses.
It's like having an AI detective that can piece together clues from all sorts of sources.
That's a great way to put it, yeah.
But we also talked about the importance of explainability.
Oh, absolutely.
Doctors need to be able to understand how the AI is arriving at its conclusions.
Right. It can't just be a black box.
Yeah.
It's not enough for the AI to just give an answer.
Right.
It needs to be able to show its work, to highlight the specific areas on the x-ray that are raising red flags.
Right.
And explain its reasoning.
I see.
That's crucial for building trust and ensuring that doctors feel comfortable using this technology.
So it's not about replacing doctors with AI.
No, not at all.
It's about giving doctors a powerful new tool to help them make better decisions.
Exactly.
It's a collaboration, a partnership between human expertise and artificial intelligence.
I think that's the key takeaway here.
Yeah.
AI has the potential to revolutionize healthcare, but it's not going to happen overnight.
Right.
It's going to require collaboration, open-mindedness, and a willingness to embrace new ways of thinking.
And a little bit of curiosity doesn't hurt either.
Oh, absolutely.
You know, our listeners are always sending us the most amazing research.
I know, it's fantastic.
And this deep dive into 4S-DT has been one of the most exciting yet.
I agree. It's a really cool technology.
It really makes you wonder what the future holds for AI in healthcare.
It's an exciting time to be alive, that's for sure.
Yeah.
And who knows, maybe one of our listeners will be the one to discover the next big breakthrough in AI-powered medical diagnosis.
That's a great thought. So to everyone out there listening, keep exploring, keep asking questions, and keep pushing the boundaries of what's possible.
Absolutely.
You never know what amazing discoveries you might make.
And thank you for joining us on this deep dive into the world of 4S-DT.
It was a pleasure having you here.
The pleasure was all mine.
We hope you learned something new and came away feeling inspired by the incredible potential of AI in healthcare.
I hope so too.
We'll be back soon with another deep dive into a fascinating topic.
Looking forward to it.
Until then, stay curious.